Hi, my name is Isaac, and this web lecture series will aim to introduce you to web programming. This includes the fundamentals of web programming, the HTTP protocol, creating and styling web pages with HTML and CSS, creating interactive web pages through HTML forms, and tools that will help you along the way. If you know nothing about web programming, that's fine. This is aimed to be a beginner level series. So let's begin. In this first video, we're going to take a look at a brief overview of the internet and the protocols that govern it, HTTP and how it's implemented through client-server, and how all of this fits into the context of this course. Before we begin building web pages, let's take a step back and see how the internet works. The internet is a network of networks and allows us to share information with anyone across the globe. Here we have a simplified diagram of the internet. We can see that our laptop can connect to a server that may be on the opposite side of the planet. This is achieved by allowing each local network to know where other networks are. So when you connect your laptop to Uniwide, you can then send a message to someone's mobile phone that may be connected to the internet through the 4G wireless network. Next, we have the World Wide Web, or simply web. It is a way of accessing information over the medium of the internet. It is an information sharing model. However, information is not accessed in a linear fashion, but allows other documents to be connected using hyperlinks, forming a huge web of connected information. For example, on Facebook, you have many different links in which you may choose to click next, and every person may choose a different link. The web utilizes an internet protocol known as HTTP. We access a web page via a uniform resource locator, also known as a URL. First, we specify the protocol, which we are going to use, HTTP. We then specify our website address, which is similar to looking in the root folder of a particular computer. In our case, we want to look in the root folder of www.csc.unsw.edu.au. From here, we can then specify a path on the website to look for a specific resource. Here we're going to look in the web folder for a resource called page.html. An important thing to note is if we don't specify any resource, say we ended the URL after web, the website will return to you the first resource that has the name index. Quite often, it will be an index.html file. The sole reason the internet can exist and function at scale is by defining a series of rules and protocols that each connected computer must follow. That is, a way of asking for, sending, and receiving information. For example, if I have a pizza and you would like a slice, then we may use a protocol to transfer that slice. You must say, "Hey Isaac, may I have a slice, Joe?" This allows me to know that you want something from me, and that something is a slice of pizza. By signing your name, I will also know who to send the pizza to. I will then respond, "Sure," informing you that I will actually send the slice of pizza. These rules ensure that I can successfully send you a slice of pizza through knowing who the sender is and who the receiver is, specifically what the requester is asking for, confirmation that the requested resource is being sent, and then actually sending the resource. A few examples of internet protocols include HTTP, which stands for Hypertext Transfer Protocol for sharing web pages, FTP for file transfer, and SMTP for email transfer. For this course, we're going to focus on HTTP, but let's take a step back and look at why. Our goal is to build a web service that someone with internet access can use. The way we do this is by creating a server-side web application that utilizes client-server architecture and the HTTP protocol. Let's break that down. We have some resources that other people want to access, which in our case is going to be HTML web pages. We allow people to access these web pages through a web server, which in our case is going to be a Flask application. We refer to this setup as client-server architecture, where we have a single server running that is responding to requests for resources from multiple computers that we refer to as clients. This is where HTTP comes into the picture. The client requests the resource via a HTTP GET request, where it sends the server a message asking for a specific resource. The server then responds to the request by sending back the requested resource. Let's have a look at accessing Facebook. First, you open a web browser, for example Google Chrome. You then type in www.facebook.com. Then what happens? A HTTP request is sent across the globe to Facebook servers before they send you a response that contains the web page that you were asking for. So you may be thinking, what do these HTTP request and response messages actually look like? Here we have a typical request message. The request message will specify what type of request it is in the first word of the message. Here we have a GET request. We will then specify what resource we are after. Here we have index.html. HTTP has evolved over the years and has different versions. Hence, we need to specify in our request what version of HTTP we are going to use. Here we are using HTTP 1.1, but HTTP 2.0 is the latest version. Lastly, we need to specify what computer or host we are asking for this resource from. Here we are asking for www.site.com. Here we have a typical response message from a server. It has two main parts, the header of the message and the actual resource being sent back, known as the content or the message body. The header is composed of a status line containing the HTTP version and response code, and the response header fields. The response header fields may vary depending on the server and the HTTP version. Common fields include the date, content type, and content length in bytes. The message then has the actual content being returned. Here we have a very basic web page. Let's now navigate to a web browser and look at the real thing. This is the Wikipedia page for HTTP. To see the HTTP request for this page, we're going to utilize the Chrome developer tools. We can access these by right-clicking on the web page and clicking Inspect. You can see that down here. Initially, this is going to show us the HTML elements of this web page, but for now, let's click Network. For now, it shows no activity, but as soon as we press refresh, you'll see that we have a bunch of activity pop up on the right-hand side of our screen. The first result details information about the HTTP request and response for the web page. So let's click on it. Over here, we can see information about the HTTP activity. Now, if we scroll down, we can see a section that says request headers. This is essentially the message we sent to the server asking for a specific resource. Here we can see that we are asking for the Hypertext Transfer Protocol web page, and we're asking via a GET request. Don't worry too much about the other information for now. If we scroll down this web page a little bit, we can see that there are a bunch of different types of HTTP request methods. The first and most common type is a HTTP GET request. This is simply when we're sending a message to the server and asking for a specific resource. The other HTTP request type that we are concerned with for this course is a POST request. This is essentially when we fill in a HTML form and send back the filled in form to the server. We will look at this more specifically when we get to HTML form. To recap, these are different ways a client can send a message to the server. A GET request is asking the server for a resource, while a POST request is sending back to the server a filled in web page. If we then navigate back to our browser and scroll up a little bit, we can then see what the server sent back to our request. The most important thing to see in our HTTP response header is that our content type is text/HTML, which means we got sent back a web page. If we navigate up here and click on response, we can then see the HTML of the web page that we were sent. With every HTTP response header, you can see that we get here a status code sent back. In our case, we got sent back the status code 304. So what does that mean? If we scroll down, we can see what these status codes mean. Most commonly, we will get a status code beginning with a 2, meaning our request was successful and we were sent back the resource we were asked for. Quite often, we will get a status code of 200. A status code starting with 3 means our request was redirected. More interestingly, a status code of 4 means there was a client-side error, meaning something went wrong on our side. You may have received a 404 error, which means the server cannot locate the resource that you asked for. In simple terms, it couldn't find the file you asked for. A status code of 5 means something went wrong on the server side. This doesn't happen very often. The reason I got a 304 is because I had viewed this web page earlier, and the web page had been stored on my computer in my cache. A 304 not modified means I can use the version of the web page stored in my cache. In this video, we covered a basic overview of the internet, a look into the World Wide Web, a quick glance at what a client is and what a server is, and the HTTP protocol.